opening the class now. So we'll be looking at break-even point. So for those of you who are joining for the first time, those that are taking management and financial accounting, this is one topic which is intersecting.
Try and be a little loud.
Okay, we are saying that for those who are doing management and cost accounting, even those who are doing in the management theory and practice, this one is a common topic that is found in both management theory and practice and cost and management accounting. So if you understand it well and good, meaning that we are killing a bird with one stone, two birds with one stone. Hello? Hello?
Continue, sir.
Okay, so we're looking at the break-even point. So this is the point at which the company is neither making profit nor loss. So at this point, the total revenue that the company is generating equals to the total cost. So that's the term break-even. So in business, you may look at it as if it's meaningless because you would wonder why should you have the income equivalent to the cost, because you're making a zero profit. Small, like you're saying, the net gain there is zero. So now this is a profit. This is a point at which the total revenue equals to the total cost. Okay, so now if you look at the break-even point, we say break-even point, which is a BEP, as you can see there. The formula is equal to the fixed cost over the selling price per unit minus the variable cost per unit. So the selling price is per unit minus the variable cost per unit. So the bottom part, where we look at the selling price per unit minus the variable cost per unit, in other words, it's also called contribution per unit. Okay? I'm sure we are together. Hello?
Yes, we are.
Okay, so we've seen where we have the fixed cost here. So break-even point in units is equal to the fixed cost over SP per unit, the selling price per unit, and the VC per unit is the variable cost per unit. So this is how you get a break-even point. So for you to understand this one thoroughly, how we use it, allow me take you to the example, which is coming from one of the papers that Mr. Njov, Mr. Collins has sent to you. I think you'll be able to see it. There's the typed one, and then there's just this one. So it's one and the same. So let's look at this example together. So example where it says Jack's Grocery. So Jack's Grocery is manufacturing a store brand item that has a variable cost of $0.75 per unit and a selling price of $1.25 per unit. So straight away, when you subtract these two, the selling price per unit and the variable cost per unit, it gives you what we call contribution per unit. So a fixed cost that is $12,000. Fixed costs are $12,000. And then this Jack Grocery current volume, they are producing currently they are producing 50,000 units. Okay, are we there? Hello?
We are there.
Okay, fine. So currently, these people, like Jack Grocery is producing 50,000 units, as you can see there. The firm can substantially improve product quality by adding a new piece of equipment at an additional fixed cost of $5,000. So the firm can substantially improve product quality. So if you want to improve the product quality by adding a new piece of equipment at an additional fixed cost of $5,000. So they are thinking of coming up with another equipment, or they can continue with the current volume of 50,000. So the firm can substantially improve product quality by adding a new piece of equipment and an additional fixed cost of $5,000, meaning that from the current fixed cost of $12,000, they will add the $5,000 for the new equipment. If they are to get engaged in that new equipment, which would push the fixed cost to $17,000. So let's look at this new equipment. So this new equipment will push the fixed cost, additional fixed cost of $5,000. Then the variable cost would increase to $1. The variable cost per unit will increase to $1. Initially, it was at 0.75 dollars, $0.75 per unit, the variable cost, the initial price. Then the variable cost will increase to $1 for the new, if they are to go and get the new equipment, but their volume should increase to 70,000 units. So for this new equipment, we increase the volume to 70,000 units. Okay, we are there.
Yes.
Okay, so you are looking at this information. If you should go for this new equipment, it will push a fixed cost by 5,000, meaning to be 12,000, the old one, plus the 5,000, which will be 17,000, and then the variable cost will increase to $1, and the volume will be 70,000 due to the higher quality product. Now the question is, should they buy the new equipment? So the question is, should they buy the new equipment? So in order for us to know if they are going to buy the new equipment, we are going to carry out analysis to see if it will be possible for them. If they are going to, the profit will increase as a result of having that new equipment, or the profit will actually be the same. Okay, so what we are going to do now is let us look at the solution. So the solution, we'll look at it. Let's look at the at the current level. At current level, we are producing 50,000 units. So what will be our total cost? So total cost at current volume will be TFC, which is the total fixed cost, plus the total variable cost. So this will be our total cost. Our total cost will be the total fixed cost plus the total variable cost. So where TFC is the total fixed cost and TVC is the total variable cost. Okay. Then our total cost is going to be, total fixed cost at current volume is 12,000 units, plus the total variable cost will be, this is the variable cost per unit, which is 0.75. Then you multiply by how many units we are actually producing at this level. We are producing 50,000 units. Okay, I'm sure you're able to get it. Hello? Are we there?
Yes, sir.
Okay, so now you multiply here the 0.75, you multiply by 50,000, then plus the 12,000, we are getting a total cost of 49,500. So the total cost is 49,500. 500. That's the total cost at the current level where we are looking at the current production of 50,000 units. Now, let's look at the total revenue at the same current level of production of 50,000 units. So total revenue is equal to price, selling price multiplied by quantity. So our total revenue is price times quantity. So our total revenue is equal to 1.25 the price multiplied by the 50,000 units that are being actually produced. Okay. So our total revenue is what? 62,500. That's the total revenue. 62,500. So if you are to subtract to find the profit here, 62,500 minus the 49,500, we are getting 13,000. This is our profit at this production level. Okay, are you getting it? Is it clear so far? Hello?
Yes, sir.
It's clear? Okay, so we have the profit we have made here for this production is 13,000. Okay, I'm sure you're able to see it, right? Let us see, communicate if you are able to get it, so that I can run through again. Because if I take you back, you can see after substituting there, we have gotten the current production was 50,000 units, and then we've gotten the total cost at the production of current production of 50,000 units. The total cost was $49,500, $49,500. Okay. Then our total revenue, we've gotten the total revenue by simply multiplying the price, selling price, by the quantity, the volume. So our selling price, we have a 1.25, then multiplied by the volume of 50,000, getting a total revenue of 62,500. Is that okay?
Yes, it's fine.
Okay, thanks very much. Then our profit, you subtract this 32,500 minus the 49,500, we are getting the 13,000 as a profit at that level. Now let's look at if they can go for this new equipment. This new equipment production volume is 70,000. We'll be able to produce 70,000 units if you are to go for this equipment. And then the total cost is equal to the TFC, that's the total fixed cost, plus the total variable cost. So our total cost here, in this case, we're getting a 5,000 plus the 12,000, because it will bring in an additional fixed cost of 5,000 according to the information given in the question. So meaning our total fixed cost comes to 17,000. Then the total variable cost per unit is $1. Now $1 you multiply by the number of units that are there that this new equipment is able to actually produce. So our total cost in this case will be 17,000 plus 20,000 multiplied by $1, which is giving us $87,000. That's the total cost. Now, after that, you are able to see that this project revenue now will be, at this production of 70,000 units, it will be price multiplied by quantity. So it's the selling price will be 1.25 multiplied by 70,000, which will give us 87,500. Now, if you have to subtract to find the profit here, you will discover that the profit for this one will be the revenue of 87,500 minus 87,000, which will give us a 500. So if they are to engage this new equipment, they are going to make a profit of 500. Okay. But if they are to maintain the old production, okay, as if I can take you back, the old production, it gave us the profit of 13,000. So in your own opinion, what do you suggest we do here?
We use the old equipment.
Yes, correct. We use the old equipment. So we are not going to entertain this new equipment because it is actually reducing our profit. So we are not going to allow it. Otherwise, he would have used it maybe if it didn't have additional fixed cost, or if it didn't push up the variable cost, maybe he would have actually used it. So, but because of that, our conclusion here is that Jack should not buy the new equipment because his profit reduces suddenly from $13,000 to $500. He will be losing out. Is that clear? Hello?
It's clear.
Okay, fine. Thanks very much. Now let's go to the other part B of the question. It says we need to find the two break-even points now. At current volume, we have to find the break-even point at current volume. So that's why we are now going to use the break-even formula. The one I mentioned, because we haven't used it. Those productions, they got them from somewhere. It was an estimate that they just estimated at current production. They didn't actually use the break-even for them to obtain those figures. So those were not the break-even figures, those ones in units. They were the 5,000, the 50,000, and the 70,000. They were not the actual break-even figures. So this is the reason why we are actually now finding the break-even at this point B. Part A is analysis where to go on and replace the equipment or use the old one. So at the current volume, selling price 1.25, variable cost 0.75, fixed cost 12,000. We substitute this in the break-even point. We are getting 24,000 units as in the break-even point in units. Hello?
Please just explain that again.
Okay, so at the current volume, we are finding the break-even point at the current volume. So current volume, the selling price is 1.25. The variable cost per unit is 0.75. So what I'm trying to say is that the 50,000 units that we were using initially, they did not find it by using the break-even point. No, it was just they are just estimated that was how much they were able to produce at that time. Hello? Hello?
Okay.
So at this break-even point, we are going to say the fixed cost. They want us to find the break-even point at this current volume. On the analysis, whether to replace the old equipment or maintain the new one, we have already made analysis there. That is already done. Now here we are just trying to find from the information given at the selling price of 1.25 for the current volume and the variable cost of 0.75 and the fixed cost of 12,000, what is the break-even point? So we're using this formula. The one I started with initially to say break-even point is over fixed cost over selling price per unit minus the variable cost per unit. So meaning the 12,000 remains on top there. Then 1.25 minus 0.75, you divide it. We are getting break-even point as 24,000 units. So the break-even point in units here, we are saying is 24,000 what? Units. Okay. Using this information here, from the I don't know if can I take you back to the question?
Yes, please.
Yes, please.
Okay, let's go. Let me take you back to the question. The question here is here says Jack's Grocery is manufacturing a store brand item that has a variable cost of 0.75 per unit and the selling price of 1.25 per unit. You've seen it, eh? These two. Then the fixed costs are $12,000. That's the fixed cost. You're there?
Yes.
Okay, fine. So meaning here, ignore this ignore the 50,000 for now. This one was an analysis based on the first one, whether to replace, okay, this old equipment was able to produce these units, not at break even, not at break even. It was just able to produce these units, not at break even, no. Okay.
Yes.
Okay. So meaning if this information here, we are using the current information that we have, they want us to find the break-even point. So our break-even point here, that's why we came here to say, our break-even point here will be fixed cost of 12,000 minus the selling price per unit minus variable cost per unit, which is giving us 24,000 units. After we substitute here, subtract the bottom part, divide into the numerator, we are getting the 24,000 units as the break-even point in units. Is that okay?
Yes.
Okay, so when you get the 24,000 units there, then if you want to find the break-even point in dollars, you will get the 24,000, then multiply by the selling price per unit of 1.25. So you're getting the break-even point in dollars. We are getting the $30,000. So this is the break-even point in dollars. In units is 24,000. Is it clear on this one?
Yes, sir.
Yes, sir.
Okay, let's now go to the new equipment. Also, let's find the break-even point now for the new equipment. So break-even point for the new equipment, selling price per unit is 1.25, variable cost per unit is $1. The fixed cost for this one is 17,000, right? So the fixed cost for this one is 5,000 plus 12,000, which is giving us what? 17 what? Which is giving us 17,000 here. So 5,000 plus 12,000 giving us 17,000. So we put the 17,000 as a fixed cost on top there. Then over the selling price per unit minus the variable cost per unit. So meaning to be 17,000 over 0.25. When you subtract the bottom part there, then you get the 68,000 units. That's a break-even point. So meaning those other figures, the 70,000, those ones, and the 50,000 that they gave us initially, they were just assumptions that those machines were able to produce at those levels. They didn't choose the break-even formulas to come up with those figures. Is that clear?
They said they didn't use the break-even point to come up with the formula.
Yeah, if you go back to the original information, we had the 50,000 units that were produced somewhere, not so?
Yes.
And we had the 70,000 units that were produced somewhere for the new equipment. So those ones, they just said those were the level of productions at that level, but they didn't compute those units using the formula, this formula for break-even point.
Okay, now I get what you're saying.
That's what I'm saying, that they didn't use the break-even point formula to compute those figures. They were just saying that one, they could have produced that machine at the target of producing 50,000 units for the current one. and the new one
Mhm.
are the target of producing a 70,000. So it's not like they are computed them using the BEP formula. So here, this is when now they're asking us now to find the actual units that these equipments were supposed to produce. Is that okay?
Yes, sir.
So this is the break-even point in units for this new equipment. Now multiplied by the selling price per unit, so you're getting $85,000. That is the 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 break-even point in dollars for this equipment, the new equipment. Break-even point in dollars, $85,000. Okay. Now part C of the question says develop a break-even chart for the problem in A above. So develop a break-even chart for the problem in A above. So break-even chart for the problem in A above. Okay, so meaning we have to come up with a break-even chart for the current volume and also the break-even chart for the new equipment. So now for the current volume, let's do this. What is our total cost for the current volume? The total cost is equal to the fixed cost, which is 12,000 there. If you can see at the corner there, a fixed cost is 12,000 plus the variable cost, total variable cost of 0.75 Q. Okay. Then the total revenue under here, under the horizontal axis is the quantity. So our quantity should be horizontal axis. Then the vertical axis, this one is where you have the total revenue. Also, this is where you have the total cost. So you have the total revenue, you also have the total cost on the vertical axis. The horizontal axis, you have the quantity here. Okay. So for the quantity, you know for the current volume that at break even of current volume, if you go back to the current volume, the break even point was 24,000 units. Okay. You are there? Hello?
Yes.
Are we there? The break-even point was 24,000 units. We are there for the current volume. So when you come here,
Yes.
when you come to the chart here, in short, you have to graph. You have to find the equilibrium point where the total cost and total revenue are meeting. So for the current volume, they are meeting at 24,000 units, if you can see there. Then, and the total cost is 30,000. So here there was an interval 5,000, 10,000, 15,000, 20,000, 25,000. There was a difference of 5,000 each on the vertical axis. Then the horizontal axis here, we have 4,000, 8,000, 12,000, 16,000, 20,000, 24,000, 28,000, 32,000. So should you say if the total in this one, so substituting, if the quantity is zero, if the quantity is zero, what will be the total cost? So when the Q is zero there, what will be the total cost? So the total cost will be 12,000. That's why this total cost is starting at 12,000 there. You're getting my point? Hello?
Yes, we are.
Yeah, so
Yes, sir.
yeah, so we are saying if the quantity is zero, meaning substituting this total cost function, if the quantity is zero, you will discover that your total cost will be 12,000 here. Then should you substitute any quantity from this range of quantities that I've put in the horizontal way, 4,000, 8,000, 12,000, but better you use the break-even point that you have already calculated there, because this is a point that you know that this is a point where the total cost and total revenue are intersecting. So that's why I had used this. Just use 2 points to plot. So if you substitute 24,000 units for the break-even point for the current volume, we are getting what? We are getting the 0.75 multiplied by 24,000. If you have a calculator, you can confirm. Then you plus the 12,000 is giving us a 30,000. Okay? If you're able to calculate that, you can calculate the 0.75 multiplied by quantity of the break-even that I'm using. We are drawing the break-even chart. So to draw the break-even chart, use the break-even units that we want to be calculated for the current volume, which is the 24,000. So you substitute there, then we are getting 30,000. Similarly, when you use the total revenue is equal to price times quantity. Our price was 1.25, and the quantity you put the 24,000 units at break-even point. So the total revenue will also give you the 30,000. If you can substitute the 24,000 in the TR bottom there, you find that the total revenue and the total cost will actually be the same. Then the fixed cost that I drew here, the 12,000, is constant. So from the 12,000, this arrow, this graph that comes here should be just constant because it doesn't vary with production. So the fixed cost here does not vary with production. This fixed cost that you are seeing there. Then the total revenue, if the quantity is 0, total revenue also be 0. That's why starting from 0.0 there, this total revenue, this one here is the total revenue. You've seen the one I'm showing? Hello?
Yes, we have.
This is the total revenue function. So this total revenue, if the quantity is 0, that's why it's starting from 0. If the Q is 0, then the total revenue also be 0. But use only 2 points to plot. So if you are going to use another point, you're going to substitute the break-even quantity of 24,000 units, so it will intersect at the same point. That's why it can go up and up and up. So meaning this level is a level of a loss. This level is a level of a loss because the costs are above the revenue. So the company will start making profit at this point. So this point is called margin of safety. The point after the break-even point is called margin of safety. So just after this point, when this graph is going up, the total revenue graph is going up above the break-even point. This area is called the margin of safety. Margin of safety, the company will be safe to make a profit. So the plotting of the graph, in this case, you only have to say, use the total revenue at quantity 0, what will be your total revenue? So, and if you have quantity of 24,000 units, what will be the total revenue? Okay, so they are intersecting at this point. So this is for the current volume. So you only have to do that one for the current volume. So even your task now is for you to do the one for the new equipment. You're supposed to graph it like this, using the information from the new equipment. So I want us to quickly move to the other one. So here so now draw for the new equipment. So using this information, we're supposed to graph the, as it were, we're supposed to graph using the new equipment, supposed to graph the break-even chart like this one from the current volume, where we had the total cost and the total revenue like this, supposed to graph like the way it has come like this. The fixed cost doesn't vary with production. I don't know if you're clear so far. Hello? Are we there?
Yes, sir.
Okay, let's now look at the part D, the last part of this one. Part D, quickly, we can look at this part D for pay. This one is part of the questions that has been sent. So you just really need to go through, and you'll be able to understand where you have a challenge. You will still come through and we'll still explain So we will pay and Sons as fixed cost of 10,000 for the period. So that's a fixed cost. Okay. Their direct labor cost is 1.5 kwacha per unit. So these are variable cost per unit. So this is a variable cost per unit. So direct labor cost is 1.5 per unit, and material input cost is 0.75 per unit. So meaning the total variable cost will be, you add and then the selling price per unit is 4 kwacha. So the selling price per unit is 4 kwacha. Calculate the break-even point in units. Calculate the break-even point in units. So first of all, we have to look at the total variable cost per unit. So total variable cost per unit in this case, you're going to add the 1.5 plus the 0.75, you get the 2.25. The selling price per unit is 4 kwacha. Are we together there? Are we together?
Yes.
So the total variable
No,
cost,
no, we're not.
the total variable cost per unit, you look at the 1.5, it's a direct variable cost per unit is 1.5 per unit, and material cost per unit is 0.75. So the total variable cost, you add the 1.5 and the 0.75, those are the variable costs per unit. So the total variable cost per unit is 1.5 plus 0.75. We are getting the 2.25. So these are variable cost per unit. The 1.5, we put the 1.5 is the labor. Okay, for you to produce a unit, there's a labor cost per unit, and then there is also a material cost per unit. You understand that? Hello?
Yes, sir.
Yeah, so you find the total variable cost per unit is 2.25. So meaning that the break-even point will be fixed cost of 10,000 units, then minus the selling price per unit is 4, and then minus the variable cost per unit, which is 2.25. So the break-even point for this one, we are getting the 6714.2857 units. Are we together?
Yes, we are.
So that's what we have there. Then in kwacha, you multiply the selling price, the break-even point in units multiplied by selling price per unit for you to get the break-even point in kwacha. Is that okay?